Hey, I'm that math girl, and today we're going to be talking about the 4 big derivative rules. So that would be the power rule, the product rule, the quotient rule, and the chain rule. So we're going to go over these one by one, and we're going to talk about why they're important and where you use them, okay? So first, let's start out with the power rule, okay? Formal definition of the power rule is written as ddx. ddx is just a fancy way of saying that you are taking the derivative with respect to x. So for example, if you were taking, this would be of f of x, but if you were taking the derivative with respect to t, then you'd probably be taking a function like this. It could look something like 2t or 2 to the t, anything where t is the only variable. So that's the same thing with x. So anything in this function where x is the only variable. Okay, so the formal definition is ddx of f of x is going to be n times x n minus 1 to the n minus 1 power, okay? Now, what does that mean? In this case, n is a constant, okay, and x is your variable. Okay, so what does this look like in practice? Let's say you have a function x cubed. Okay, to use the power rule on this, it would bring down the 3, because that's your constant, that's going to be your n. Okay, and then you do keep that x right there, and notice that in the exponent we're subtracting 1 off of it after we bring it down. So 3 minus 1 is 2. Okay, that's how you apply the chain rule on this. Now let's pause for a quick second and let's talk about where and how you use the power rule. Why do you use the power rule? So power rule is going to be used in exponential functions that look just like this one. So like x squared, x to the 4th, x to the 5th. Honestly, anytime that there is a variable to a constant, that's when you're going to use it in this form. When you're not going to use it is when you have a constant to a variable, or if you had x to the 3x, that's when we're going to use the chain rule. Okay? So anytime you see anything that looks like this, it's just a variable to a number, that's when you're going to use it. Okay? Okay, let's do a couple more examples just so we can fully understand what this looks like. So let's say we had x to the 5th. I'm going to bring down that 5 because that's your n. Keep that x right here, and then subtract 1 off the exponent. Okay, one more. So you had x to the 6th. I'm going to bring down that exponent, keep that x right there, and subtract 1. There you go. Okay, that is the power rule. Okay, next we're going to talk about the product rule. Okay, the product rule formal definition is written ddx of f of x times g of x, which we'll talk about what that looks like in just a moment, equals f of x times g prime of x plus f prime of x times g of x. Okay, let's break down what this means. For starters, the prime notation you see here with the little almost apostrophe sign, that just means derivative of. Okay, so what might a function look like that looks like f of x times g of x? So an example might be if you had a function like this, y equals 2x minus 1 times 4x plus 3. Okay, 2 separate functions, 2 separate derivatives. Okay, And so the real thing is here, you can really switch these around. So if you wanted to do f prime of x times g of x or g prime of x times f of x, I mean, this is commutative, or commutative, but this is how the rule is written. So whatever way makes most sense in your mind. Let's go ahead and take the derivative here on this product rule, okay? So let's identify what f of x is and what g of x is. In this case, I'm going to call f of x 2x minus 1, okay? And we're going to call g of x 4x plus 3, okay? Now I'm going to take the derivative of f of x. So the derivative of a constant is always 0. And the derivative of x is 1, but it's multiplied by 2, so it's just going to be 2. Same thing here, g prime of x. So the derivative of 3 is going to be 0, and the derivative of 4x is going to be 4. Okay, now let's plug this into our product rule. So y prime equals f, so 2x minus 1, times times g prime 4 plus f prime of x, which is 2, times g of x, which is 4x plus 3. Okay, now let's go ahead and multiply this out. So we're going to get 8x minus 4 plus 8x plus 6, and then we can go ahead and just combine like terms, 16x and then plus 2, okay? And that is what the derivative of this function is going to be. Alternatively, you could, in this specific case, multiply this out using the FOIL method, but if, for example's sake, that's how you do the product rule. Okay, so now we're going to talk about the quotient rule. Quotient rule is very similar to the product rule. Here's the formal definition. So we have d dx, a function that looks like this, f of x over g of x. Okay, so just one function being divided by another. Okay, and this is what the rule is going to be. We're going to do g of x times f prime of x minus f of x times g prime of x over g of x squared. Okay. Notice the difference here from the product rule. There's a minus sign and there is a squared. Both of those are really big and very common to forget. But the general form of the top with the g times f prime of x and the f of x times g prime of x, that's the same form as the product rule. So what's a case we would see this in? Let's say we had 3x over 2x. Okay, we're going to set this up the same way we did with the product rule. So our f of x is going to be our 3x. G of x is going to be our 2x. Then our f prime is going to be 3. And our g prime is going to be 2. Okay. So now let's plug this into our formula. So y prime equals, so let's plug in our g, 2x times f prime, 3, minus f of x, 3x, times g prime of x, 2, over, oh, that was a not straight line, over g of x squared. So that's going to be 2x squared. Okay, multiply that out, we're going to get 6x minus 6x over 4x squared, which equals 0. You may be wondering, why is this 0? Because usually the derivative is only 0 if it is a constant. But let's take a closer look at our original function, okay? 3x over 2x, if you look, these x's cancel out. So this really is just 3/2. So the derivative of 3/2 is going to be 0. Why did I choose that example? For simplicity's sake. For the most part, your answers are not going to be 0. But let's do another example so we get the complexity down. Let's try something else. Say y equals 5x minus 15 over 2x plus 3. Okay. Set it up the same way. We have f of x is equal to 5x minus 15. G of x is equal to 2x plus 3. F prime of x is going to equal 5. And g prime of x is going to equal 2. So now let's plug it into our formula. So if you recall, it's going to be g. So 2x plus 3, I would recommend using parentheses so you don't get confused, times f prime, which is 5, minus f, which is going to be 5x minus 15, times g prime, which is 2, all over g of x squared. So it's going to be 2x plus 3 squared. Okay, let's go ahead and simplify. So we're going to turn this first part into 10x plus 15, keep those parentheses, minus 10x minus 30. Remember, for this bottom part, we can't just distribute the exponent in. So if you write it out like this, we can use the FOIL method, okay, which is first inner, outer, last. First outer, inner, last. So we have 2x times 2x is going to be 4x squared, first inner, plus 6x plus 6x plus 9. Make sure you keep your signs real tight on these. So we're going to end up with 4x squared plus 12x plus 9. So you can go ahead and plug this in over here. 4x plus 12x plus 9. Okay, let's go ahead and see how else we can simplify this. These 10x's are going to cancel out, and you're going to be left with a negative 15 on the top over 4x squared, oops, forgot the squared here, plus 12x plus 9. Okay, that's going to be how we use the quotient rule. Okay, the last rule we're going to talk about is the chain rule, which is arguably the most complex derivative rule you're going to learn in Calc 1. It's also the most important, so let's go over this carefully. So, formal definition is d dx of f of x to the n. Okay, we'll talk about what that looks like in a minute. Equals n times f of x times n minus 1 times f prime of x. Okay, so this is kind of a variation on the power rule. If you notice, this part is the same as the power rule. Okay, we just have this little chain link added on here. So what would a function like this look like? How do you know when to use the chain rule? I would say a function that looks like this: x squared plus 1 cubed, or 4x to the 4th to the 12th, anything like that. So we have a function here raised to another power. And you can't take the derivative of the inner part until you deal with the outer part. So what we're going to do is we're going to follow this power rule. So let's use the first example. X squared plus 1 cubed. So first thing we're going to want to do is that first chain link is just a power rule. So we're going to bring down that 3. You're going to keep that inside function exactly the same as you saw it. And then you're just going to subtract 1 from that exponent. So you keep that squared. Then you're going to multiply by the derivative of the inner function. So 2x right here. Okay? You can go ahead and simplify that. We get 6x times x squared plus 1 squared. Okay? Let's try another one to drive the idea home. Let's do our second example we have up here. So we have 4x to the 4th raised to the 12th power. Again, we're just going to do that power rule first. Bring that 12 down in front, keep that inner function exactly the same, and then subtract 1 from that exponent. And then we're just going to multiply by that chain link, okay? So we're going to multiply by 16. If you notice, we brought down that 4, so 4 times 4 is 16, x to the 3rd, okay? You can multiply out 12 times 16. I am not going to do so, so I'm going to call this my final answer. And that is all 4 derivative rules for you. Let me know in the comments if you have any questions and also what math topic you would like me to cover next.